All right, welcome to the unit on quadratic functions. We're going to be looking at different ways to graph and work with the quadratic equations that you come up with throughout the unit. So we're going to start here with the pumpkin chucking festival. Should have already showed you a video on this, just kind of what it looks like. And we don't really need to label the axis, but you should understand that there's basically a path that's being thrown that's going to look like this. This is what the object would look like, the pumpkin in this case, which is going to start at an initial height. Okay, we're going to call this h0. And it's going to shoot off at initial velocity. We'll call that v0. And then the gravity is going to pull this back down. But this general shape, this U shape, is what we call a parabolic curve. And that's what we're going to be studying in this unit. So one of the engineers designed to shoot a pumpkin. It was 20 feet tall, shoot an angle 45 degrees. There's no gravity. What would it look like? Well, no gravity would look, again, initial height here, velocity shoots out, but since no gravity is there to pull it down, it's just going to be linear. So what would the equation be? Something like, 20 plus 50x in this example. If it was 30 feet tall, what it's going to do, pretty much just start higher. So if you look back up here, it's just going to start, at 30 feet instead of 20 feet. So these are really the things that are going to matter when we come down to the parabola, the three pieces: height, the velocity, and the force of gravity. And we're going to use this throughout the unit as the main concept. And what I want to really show you in this lesson is how to use the calculator to help, because this is where, with lines and exponential functions, there's really not much of a need for the calculator, but we're going to start to get into analyzing graphs at this point. So here's the formula just to find the distance that a pumpkin will travel. H equals h0 plus v0 t minus 16t squared. And it's the three pieces we talked about before: the initial height, which is h0, the initial velocity, which is v0, and then the negative 16t squared, which is gravity. So for example, if a pumpkin leaves a cannon at a height of 15 feet at speed 55 feet per second, the equation that we're going to use is going to be 15 plus 55t for time minus 16t squared. And that'll be the equation that we can use. So what I want to do first is show you how to get this equation on one of your graphing calculators. So whether you have this or this, we'll go through both of them. So if you have the Inspireds over here, and if you have the 84 pluses over here. But to graph these for both of them, so let's use the Inspire first. You're just simply going to start here, 15 plus 55x minus 16x squared. And what we need to do is adjust the window. So in order to adjust the window on this one, because we don't want to, you look, the graph's really not here. We're going to hit the menu button. We want to go down to where it says Window Zoom in the settings. And this is where we need to understand the equation that we're doing, and it's going to take some practice, but you need to understand what equation we're doing. X min and X max is time. So in this one, it's probably not going to last more than 6 or 7 seconds in the air. So I'll just go say 7 seconds. The Y values are how far vertically and horizontal, or how far vertically this is going to travel. So we know the minimum is when we want to see it hit the ground. The maximum, let's just take a guess. Again, maybe it'll go 100 feet up in the air. In there, we have a nice picture of the graph. And then we can use things later on, which we'll learn about how to find the maxes, the mins, where it lands, and whatnot. But you should be able to get this graph up here with, again, understanding how this equation works, which is it starts at 15 feet, shoots out at 55 feet per second, and comes down, and then use some kind of logic and common sense to figure out how long is it going to be in the air on the x-axis, and how high is it going to be on the y-axis. We're going to do it on an 84, 15 plus 55x minus 16x squared. And you're going to hit the window here and do the same thing. So once you, instead of graphing it first, hit the window button and adjust it. 0 to, let's say, 6 seconds. I'll change this up a little bit to make it look a little bit different. So maybe we think it's going to go maybe 75 feet in the air. So again, the X values are the time it's going to take to land when the pumpkin's being thrown, and the Y values are the maximum and minimum heights. So it looks something like that. Now, every graph can look a little bit different. That is okay. This, as long as you understand, how to use that formula and where to go from there. So what I want you to do now is flip back over to here. So we're going to use a stopwatch to determine the velocity, shooting at a height of 10 feet, and it's going to land in 6 seconds. So I'm going to show you how to do this on your calculator again. So let's go back to our two calculator screens. So now what we have is, it tells us that we are going to start at 10 feet up in the air, but it doesn't tell us the velocity. So I'm going to guess the velocity. Let's just say 50 feet per second. And we want to know, we want it to have it land in 6 seconds. So what I'm going to do is I'm going to adjust my window so that it lands in 6 seconds. So our goal is now to increase the velocity to get this to land here. So why don't you pause the video, and if you're over here, same thing, we can put the 10 here, and we'll just guess a speed of 55. I'm going to adjust my window to 6 seconds. And what I'd like you to do is, right here, if you look, 1, 2, 3.5 seconds, we want to get it to land in 6 seconds. So what velocity can we change this to get it to land at 6 seconds? So pause the video and see if you can come up with the right solution. So if you take a look at the 84 plus that we have over here, it's a little easier to see. So I'm just going to shrink this one and we'll kind of look at this one. So it starts at 10 feet and lands here. So notice this almost 6 seconds. So I would say this is pretty good. It doesn't have to be exact. We'll work on that later on. What speed did I use? I used 92. So maybe if you want to just increase this to 93, let's see if it kind of hits it more perfect. Okay, but close enough so it's going to land in about 6 seconds. And this is a way that you can just adjust your window, practice working with your window and understanding what that middle term does. What I'd like to do now is let's graph this. Let's do the same thing with this graph and see if we can make predictions based on this graph. So in order to do this, we're going to have to put this data into our calculator. Now to do that, if you have one of these 84 pluses, what you're going to do is hit Stat, Edit, and then in L1 and L2, you're going to put this bit of data. So why don't you pause that now and put that data in. If you need to do it on the Inspire, what you're going to do is hit the document key, or you can go to your home screen and just create a new document. And we're going to create a list and spreadsheet and put these values in. So pause the video, put these values in. All right, so hopefully pause the video to put these in. One of the things to make sure of if you're in Inspired is to go up here, skip the equal sign, go up here to where this tag mark is and type in time and height. You'll need that. Hit the go back to the document screen. Go to your unsaved document, sorry. So when you're here, so what you're gonna do is you're gonna hit Control plus page, and you're gonna add data and statistics to get this screen. Once you get here, click on the bottom, you're gonna put the time on the bottom, go over to here and click the height. And that's what you're looking for. On a 84 plus, what you're gonna do is you're gonna hit zoom, and you're gonna go down to 9 for zoom stat. Again, if the points do not appear, go to your stat plots. So go to your y equals screen and make sure that your plot 1 is turned on. So notice it was blank. And now if you hit zoom stat, it should work and you get the stat plots turned on. What you want to do here is let's create a function that goes through this. And the way to do this, pretty simple. If you hit the menu button on this. So if we go over here and hit the menu button, go to Analyze, and go to Plot Function, what that will allow us to do is just put an equation here. So we know it starts at 15, we'll guess 55 feet per second minus 16x squared, hit the graph, and it's close, so we're going to have to adjust this a little bit. So you might have to, double click on here and maybe increase the speed to some other number. If you're going to do it over here, you just go to the y equals screen and then you can plug it in here. So what I'd like you to do, and then get credit for the day, is to find an equation that models this situation that goes through these points the best. Show it to me and receive your credit. Best of luck.